Welcome back again, and what we have is a Pyle Power PLA2678 4,000 watt amplifier for you, 2-channel MOSFET amplifier that I had purchased for this video. So I will read you the description of what I bought. So it says, inoperative, does not turn on. It smells burnt. And yes, trust me, this does smell burnt. It says moderate wear. Item smells burnt, suggesting interior damage. Very clean. I will agree with the seller of this amplifier. It is a very clean amplifier on the outside. So the one thing I'd like to point out is when I opened the box, something surprised me. This fell out of the box. And if anyone has done any form of amplifier repair or even just circuit repair, they would already know what this is. This is a trace that literally fell out of the box. And the amplifier is not opened. I have not opened this. The seal is still, I do believe, intact on this. Actually, this does not have a warranty seal. Yeah, so I do not see any signs that this has been opened before. So let's open it up and see where that trace came from. This ought to be interesting. I'm assuming this is a 2-channel, so it's going to be a class AB amplifier. On the back here it says 4,000 watts max. 12, well, it says 12 DC, 14.4 volts DC, so 12 to 14 volts, negative ground, just a common automotive amplifier. Made in China. Let me just pull these screws off the back, and we will see if I can get this cover off without having to pull the end plates. Oh, I sure can. Oh, it didn't overlap as much as I thought it did. So we're going to open that up and see what we got. And just upon initial first inspection, I do not see any burnt areas on the top. I don't see any transistor legs that have separated from fatigue. So I don't see any signs of vibration damage. It definitely does smell burnt. I can smell it. It's very strong, so I'm assuming on the underside of this board we are going to find that a significant portion of the track is burnt. Oh, actually I found the problem of this amplifier. I'm going to see if we can get this on camera, because this is a very interesting failure. I'm not sure if this is a failure or if this amplifier got dropped, or did it just cook from an overload. This one's pretty interesting. Let's see if I can get it on camera here. So I think you can just see it, but there's a crack in this board starting right here, cracks all the way through, goes through all these traces all across. There's pieces of the board here that's physically burnt. Let me just pull some of this away, and there's a hole completely through this all the way to the case. So surprisingly, it looks like this board either cracked from being dropped, or if it simply has just been overloaded to a point where the board flexed and cracked. So I will do my best to rebuild this board, put it back together, secure and support the PCB to where it doesn't crack and flex any further, and we will go from there. Alright, so I took all the screws out off camera so I didn't have to bore you with removing screws, but you remove the screws, took the end plates off, so then the board will slide right on out of the heatsink here. It should slide right on up out of here. And so then we will see this board together for the first time here. So, sorry about that noise there. Wipe off the thermal paste off my hands there. All right, let's flip it over and see what we got going on here. Oh, and I just wanted to point out too that let me get rid of this mica. Any other micas floating around? I'd like to point out that this board is very, very thin. It's the thickness of this board is some of the thinnest that I've ever worked with. So when you read the brand name Pyle, you probably have already determined your own definition of this manufacturer, or not manufacturer, of this particular brand. So there's what we got. We do have a complete hole right through this board. So I know if you're a amplifier technician right now, you're saying, well, this board is definitely not economical to repair. Which I would agree with you. If this was a customer's board, I would definitely contact them, let them know the extent of the damage and what it would cost for the repair of this. And you can, as you can see, even over here, the trace has been pulled up off the board, which will have to be repaired, of course. So the best thing when you get a board like this in is the best thing to do is to not disturb the area, especially if it's a board you're not used to working on, working with, or understand the topology of how it's laid out. Because as it is right now, the way it sits, I have a full idea of where each trace goes, where the jumpers go, what everything leads to. So I'm able to put this back together without any concerns of having a short when I fire it back up. So you know right off the bat that the power supply on this is a full rebuild. It's a trace repair, it's going to be a PCB repair, and it's probably going to be, I'm going to assume it's going to be output transistor replacement. So let's just check real quick the output transistors on these. So your meter in continuity mode, diode mode on the meter. I use a Fluke 87 for my meter. So we're just going to go through and we are just going to check the output transistors to see if any are shorted. At this point, I don't care about polarity of my leads. What I'm just looking for is just that short across any legs of the outputs. because one of the first things you got to do when you repair an amplifier is you got to determine if you have them on hand and if you can find them if you don't have them on hand, and hunt them down if they're hard to get a hold of, which I do have a few people throughout the United States that I keep business cards handy because they do stock the hard to find obsolete parts. So typically I'm not afraid of not having the part or being able to get it. So I can pretty much repair, so far I've been able to repair pretty much any amplifier that's come across my bench. So let's see, these use the typical the 50 N06s and the typical 20 amp rectifiers. Just double check the rectifier. If you use just a little bit of thermal paste and if you wipe it across the top of these transistors, you can typically read the value easier. That makes those numbers stand out. So these are the 12820. So these are actually smaller. Yeah, these are 12 amp 200 volt rectifiers. And your outputs are your typical 1941 5198s, which I do have those on hand. I try to keep a good supply of those. So yeah, this is not going to be a impossible repair. So tag along on this journey. It's going to be an interesting journey to learn how to repair PCBs and repair traces. Thank you for watching, and we will continue. Alright, so the first thing you got to do on a burnt board is you have to get rid of all this carbonized PCB, because this is electrically conductive. So what I'm going to do is I'm going to take my tweezers and I'm just going to make an outline of where the carbonized PCB is. And for all you viewers that don't like the sound of fingernails down a chalkboard or something of the sort, sorry, but I just gotta scrape away this carbonized board here. So what I'll do is I'll lift the traces, keeping the trace intact of the jumper that it's going to, and see what part of the board is burnt and what part can be saved. So I just go through and I just determine where I gotta cut the board out and replace the board. Just remember, you gotta get it all. And then when you do get to places that has your jumpers, diodes, and resistors in place, you got to kind of peel back the carbonized board around those traces. It just helps keep you on track of where things go, the orientation, especially if it's a diode, because you're going to lose all your silk screen on the other side telling you the directions. I have already taken the pictures of both sides of the board, so I know where the components go and in what direction. So it looks like we got 1, 2, 3, 4 layers of this board. 1, 2, 3, 4, and I don't believe this is a fiberglass PCB. Yep, and then as I continue to snap off the board in the areas that are carbonized. That's why I use sharp tweezers. It'll poke right through the carbonized board, but it won't poke through the board that is not carbonized. Just kind of tells me where to go. It gives me an idea of the extent of the damage. And let me pull this section out, and I'll be right back so you don't have to listen to all this scratching and poking going on. Alright, so this is where I'm going to finish dremeling out the board. I use a fine tip Dremel, and I use it as kind of like a dental tool. So I'm going to mute the sound so we don't have to listen to this loud Dremel. So I'll be right back with you. And that's what we're looking for, is just to clean out any carbonized PCB board for the rebuild of this board. And we will continue again. Alright, this is another section to the Pyle amplifier board repair. You will see that I have Captain tape on the other side of the board here to keep the epoxy in place to fill the section of the board that I use the Dremel tool to Dremel out. So now I'll go ahead and mix the epoxy and show you how I do it. So what we do is we just add 2 equal parts of A and B of the epoxy. And we're going to go ahead and stir it together. I do add a pigment to the epoxy that does give it the blue hue for the circuit board. It's just like any other epoxy, you just need to thoroughly mix the part A, part B. Otherwise it will not set up correctly for you. So I just give it a little bit of a blue hue just to blend in a little for the board. And then, alright, so I'm back. Sorry, I had kind of a interruption. The phone rang. So what you would notice here is the hole that got dremeled out in the board is now layered with epoxy. And what I'll do is, once this is set up, what I'll usually do is let this set for 24 hours to make sure it's cured 100%. And then what I do is I will rebuild these traces, and clean this board up, and I have a slight crack right through here that I got to finish repairing. What I'll do is I'll Dremel this out to a little valley, and then I will lay epoxy in here that'll hold this section together, and then repair the traces that have been damaged here. So this is ongoing, and we will be back again. Alright, here we are again. Just filling up the last sections of the repair of the board here. So I got my epoxy mixed up, and what I'm going to do is just lay it in the valley that I just dremeled out of the PCB here. And what I'll do is just fill the hole. Just like that. Fill the other hole. Just like that. And then what I'll do is I'll take this extra epoxy here that I have, and I will add it to the top of the epoxy that I just laid down earlier. To finish up the repair of this board. You'll see this one I have a little bit more blue in it. So the more pigment you add to your epoxy, the longer it's going to take for the epoxy to set up. So my first initial layer didn't have as much pigment in it, so it set up relatively quick because the Captain tape on the other side can leak in certain spots, and this is a 5-minute epoxy that I use, so it sets up relatively quick. And that way I can finish the fill since my initial first layer is already set up. So I'm not really concerned about time on this layer. Like I said, it'll sit for 24 hours before I do the trace repair. So just like that, this epoxy will flow out nice and even. As long as your workbench is even, it should flow pretty straight. So that's gonna be that repair of the board, and we will see you again in 24 hours.